Good day, it's Daniel Joseph Patlawan of BetSipat STEM, and we are the group 3 for SIPET 4, together with Alberca Dataro de la Cruz, Siring Colaman of Bumani and Quines, and Regula. We shall discuss to you the analog transmission, analog data transmission, a way where analog waves go through a physical medium to pass or transmit data. The main processing medium for their given data would be a carrier wave, a wave that passes it through a medium or through a modulation. Modulation is only then required when we needed to transmit a data which have a lot of continuous variations due to the physical phenomenon that the wave goes through. And that's where the modulator demodulator or modem is used for a data of pair of zeros and ones that a wave has. In comparing the use between the modulator and demodulator, modulation is the process of converting digital to analog signals when transmitting data. Then we have demodulation would then be the process of converting analog to digital signal when receiving data. Knowing that the carrier wave passes data through modulation in analog data transmission, the type of modulation would be the digital modulation. It tweaks amplitude and frequency since it would be received as an analog data, and modulations for these to be later on be transmitted as they would be crucial for the analog techniques. Since we've been through many technological advancements, high quality communication has been attained. It is then done within the digital techniques that improves data capacity, information security, and system accessibility, and together providing clearer and a more detailed information compared to analog techniques of modulation. For the types of digital modulation, we'll have amplitude shift key or ASK or ASK, and frequency shift key or FSK that I would be discussing. Then we'll have phase key shifting or PSK, and quadrature amplitude modulation or QAM for the next reporter, the reporter after me. So we have amplitude shift keying. Take note of amplitude, displacement of the wave from the resting position. It is a digital modulation where the basis of changing the carrier wave or M times T message signal is from its amplitude. As we can see that digital signals would either have a constant 1 or 0 for amplitude. It would then be showing a continuous analog signal in the constant 1 and would show no signal in constant 0 that would be interpreted as the modulated carrier, or the M times T times cosine omega constant times T is referred as the cosine omega constant T constant, the omega constant times T for its output carrier wave that brings in the data. The process this goes through is the amplitude shift keying, which could also be known as the on or off key or OOK. The ASK modulation, it would notably have its strength with its efficiency for its bandwidth or the range of frequencies. Having simple receiver design, making transmitting digital data over an optical fiber capable, and expensive modulation demodulation processes, and making transmitting Morse codes at radio frequencies capable via the variant OOK or the on or off keying. Sadly, it has a lower power efficiency and is extremely sensitive to noise interference when modulating, that one would rather use a binary phase shift keying or BPSK that is less susceptible to error, as its advantages and disadvantages already hinted us with its uses. Will have the ASK's applications. It is used in many automation devices, knowingly it helps with remotely controlling systems. Also in some low frequency RF application, and a fundamental between wireless base stations, being capable of the fast transmission and perception upon the use of the fiber optics. Then we have frequency shift keying, where frequency as we know of it, the number of periods it cycled from the resting position to its displacement. It is a digital modulation where shifting the carrier wave depends with the frequency the waves in comparison would have. Every signal would normally have considerable differences in its frequency, but for digital signals, knowing it has a 1 or raised signal and 0 or the resting signal difference with its amplitude, it observably has a continuous frequency every time it changes binary data values or the zeros and ones. So within the basis of change, the resulting analog signals would just have continuous wave as it should, but only differ in speed to show the difference between the frequency of a 1 and 0 digital signal, which was the omega constant 1 and the omega constant 2 or 0 respectively. With the advantages and disadvantages of the FSK modulation. For FSK, it has great qualities like having a lower chance of having an error, high signal to noise ratio or SNR, resistant to variations and attenuations that makes a higher noise immunity through the channel, and a simple transmission and reception implementations for low data rate applications. Although there are still some of the weaknesses for such modulation, as it uses larger bandwidth, making it not as efficient than ASK and PSK, and has a worse percentage of bit errors to bits received ratio, or the bit rate or the bit error rate, in an additive white Gaussian noise or the AWGN channel. Now we'll have some of the FSK's applications, as the image would really show its main use in the telemetry systems. It really could also be functional with utility metering in houses, color identifications when backtracking, and coordination in wireless base stations, again, for instant responses, especially in restaurants, hotels, shops, as they may help in paging communication systems. And now let's get one ahead with the phase shift keying or the PSK from our next report.
Phase shift keying or PSK is a digital modulation technique that transmits data by shifting the phase of a reference signal with a fixed frequency. The sine and cosine inputs are changed at precisely the right time to produce the modulation. It is frequently used for Bluetooth, RFID, and wireless LAN communication. PSK application. This method is broadly used for biometric, wireless LAN along with wireless communications like Bluetooth and RFID. First, a local oscillator. Second, optical communications. Third, multi-channel WDM. Fourth, delay and add demodulator. And last, a nonlinear effects for WDM transmission. Quadrature amplitude modulation, or CAM, this refers to a series of digital modulation techniques and closely related family of analog modulation techniques that are often employed in modern telecommunication to transport data. By modulating amplitudes of two carrier waves using the amplitude shift keying, or AS, digital modulation scheme, or the amplitude modulation, or AM, analog modulation technique. It transmits two analog message signals or two digital bit streams. COM application. In radio communication systems and data delivery applications, COM is widely used most of the high-speed data, video on demand, HD television, internet protocol cable television, and wireless cellular and digital systems are run by COM.
Hello everyone, I am Jan Jores Estetaro from BETC PET2B, and for today I will be discussing the error correction. So first, let's define what is error correction. Error correction is the process of detecting errors in transmitted messages and reconstructing the original error-free data. So the error correction, it's the job of the receiver to detect the error. So if it isn't there, it will discard it. So otherwise, it will accept it. So sa madaling salita, ang error correction ay just to accept or reject. Whereas error correction is a tedious job. So the receiver has to correct the error. So error correction, it can be handled in two ways. Number one, the backward error correction. When the receiver detects an error in the data received, it requests back the sender to retransmit the data unit. So kapag ang receiver ay naka-experience ng error, the receiver can have the sender retransmit the entire data unit. Or the number 2, forward error correction. When the receiver detects some error in the data received, it executes error correcting code, which helps it to auto-recover and to correct some kinds of error. So forward error correction naman ay pwede siyang gumamit ng error correcting code, which automatically corrects certain errors. So we have actually a formula in error correction. So for M data bits, R redundant bits are used. R bits can provide 2R combination of information. In the M plus R bit code word, there is a possibility that the R bits themselves may get corrupted. So the number of R bits used must inform about M plus R bit location plus no error information. So M plus R plus 1. So yun nga, may we formula tayo dito sa error correction. So ang M for data bits ay nagagamit ang R redundant bits. So sinasabi rin na R bits can give 2R combination of data. Sa M plus R na code word, ang R bits ay may chance na makorrupt. So the number of R bits used must inform about M plus R bit location plus no error information. Kaya nag-come up sa M plus R plus 1. That's all for error correction, and now Mr. De La Cruz will discuss the error detection.
So in error detection, when the information received by the receiver does not match the information of the sender, digital signals suffer from noise during transmission, which can create errors in the binary bits traveling from sender to receiver. So ang error po is described as kung ang information po na galing sa transmitter is hindi nagtutugma sa nakuha ng ating receiver. So this is caused by the noise or interference na nagaganap during transmission. And siya po yung nagka-create ng errors in the binary bits traveling from sender to receiver. So we have many different ways to detect errors. So ang pinaka-simple po natin na una is ang simple parity check. So sa simple parity check, pag nagsisend po tayo ng data from the transmitter via the data bits, may instances na ang data bits na galing kay transmitter ay hindi katulad ng marireceive ni receiver. This is because of the interference or noise na tinatawag natin. So possible sa data bits na ang 1 is replaced by 0 or 0 is replaced by 1. So this is caused by the noise na po na tinatawag natin. And there are two types of parity checking, the odd and even parity check. So, let's start muna po sa even parity check. So, in the even parity check, blocks of data from the source are subjected to a check bit or parity bit generator form, where a parity of 1 is added to the block if it contains an odd numbers of 1. So, meaning, sa data bits po natin, bibilangin po natin yung numbers of 1. And sa parity bit naman po, magdadagdag tayo ng isang block sa data bits na nakuha natin. So, if ang example po, ang number of 1s sa data bits natin is 3, magdadagdag po tayo ng number 1 pa sa ating even parity. Tapos nakikita po natin sa example, para maging even po ang number ng ating 1s. And if even naman po ang number 1s na nakuha natin sa data bits, we simply just add 0 to the parity block para maging even ang ating 1. So this scheme makes the total numbers of 1s even, and that's why it is called even parity checking. And then malalaman na po natin ang error sa pinakang transmission of data if hindi even ang 1 kahit kasama ang parity bits. So ibig sabihin po nito na may error natin sa ating data. And the same applies with the odd parity. And 1 is added to the block if it contains an even numbers of 1, and 0 is added if it contains an odd numbers of 1. So sa even parity checking naman po, kailangan even yung number ng 1s natin. So sa data bits naman po, hindi na natin kailangan ng even. So kahit odd na lang po yung number ng number of 1s natin, tulad din dito po sa example, 3 po yung 1 natin. So, ang idadagdag na lang po natin sa parity block is 0. And if even naman na po ang number ng ating data bits, let's say meron tayong 4 number 1s, magdadagdag po tayo ng isa pang 1 to make it 5, and that makes it odd po. So, that's the simple parity check. So, for the next error detection, we have the two-dimensional parity check. So, parity check bits are calculated for each row, which is equivalent to a simple parity check bit. Parity check bits are also calculated for all columns, then both are sent along with the data. At the receiving end, these are compared with the parity bits calculated on the received data. So, to explain the two-dimensional parity check, in the two-dimensional parity check, para rin siyang parity check na diniscuss ko po kanina, pero para siyang upgraded version which can detect burst error, since maraming data block po ang gagamitin natin para tayo ay mag two-dimensional parity check. So it organizes the block of bits into the form of table. So we have the row parities. In each row, kukunin po natin ang parity check bits nila, as we can see in the example. So if even ang number of 1s, maglalagay na lang po tayo ng 0. So as we can see in the example, lahat sila 0 since lahat po ng number of 1s is even. And next naman po, we have the column parities. In every column, chine-check din po natin if it is even. Makikita po natin sa bottom part, and makikita po natin that the first column is odd, kaya naglagay po tayo ng 1. And same na lang din po sa iba, if it is odd, we add the 1, and if it is even na, we add the 0. Yung column parities naman po ang i-add natin sa parity block bit in each data block. So, itong data po is to be sent to the receiver, and it will be cross-checked and verify if magtutugma po yung binigay nating data na kay receiver and yung na-receive po na data ni receiver. So, ayun po yung two-dimensional parity check, and ang mag-check po siya ng mga burst error. So, maganda po siya sa mga burst error since 4 block bits po ang gagamitin natin. So, in the checksum naman po, and as from the word itself, meron tayong check plus sum. So, dito po, check natin ang the sum of the blocks to verify if it has error. So, sa ating sender side, ang pinakang role po natin is to calculate the checksum, and yung checksum po natin is to be attached to the message. Now, in the receiver side, yung checksum po i-validate natin by adding the blocks again to see if there are any errors to the message. So there are steps in the checksum, so let's start with the first. In the checksum error detection scheme, the data is divided into k segments, each of m bits. So we have 4 segments here, and in each segment we have m, which is the number of bits. So we have 4 segments, and we have the m is equals to 8, so we have 8 bits in each segment. Now in the sender's end, the segments are added using 1's complement arithmetic to get the sum. The sum is complemented to get the checksum. So meron po tayo ditong, sa example natin, meron tayong segment 1 and segment 2. So i-add po natin siya by binary addition, and ang magiging sagot po natin dyan is 1, 1, 0, 1, 1, 1, 1, and 0 again. So nagkaroon po tayo ng carry dahil dito sa 1 plus 1 is equals to 0, 1. So i-add lang po natin siya sa pinakang sum ng segment 1 and segment 2, and we have the sum 0, 1, 1, 1, 1, 1, 1, 0, 0. And yung sum na po to is to be added to our segment 3. And after that, ang sum naman po nila is to be added to our segment 4. Then after that, after po makuha natin yung sum ng lahat, ang gagawin po natin is the 1's complement. So ano po ba ang 1's complement? So ang ginagawa ng 1's complement, ang lahat ng 1 ay magiging 0 and lahat naman ng 0 ay magiging 1. So dito sa ating sender side, ang sum natin is 1, 0, 1, 0, 0, 1, 0, 0. And ang magiging checksum naman po natin is 0, 1, 0, 1, 1, 0, 1, 1. So parang binaliktad lang po natin ang sum natin, and ayun na po yung checksum natin. So the next is the checksum segment is sent along with the data segments. So masasama po ang checksum sa makukuha ni receiver. So ganun lang po uli ang process. I-add lang din po uli ni receiver ang ating mga blocks, and then after po makuha natin ang sum, isasama po natin ang ating checksum. So makikita po natin dito sa pinakang sum sa dulo, since magkaparehas po ang sum dito and ang sum dito, i-add lang po natin ang checksum na galing sa ating sender papunta sa ating receiver. So ang makukuha po natin dito is all 1. At the receiver's end, all received segments are added using 1's complement arithmetic to get the sum. Then the sum is complemented. If the result is 0, the received data is accepted, otherwise discarded. So ang makikita po natin dito is ang pinakang sum po natin sa receiver is all 1's. So ang complement po ng all 1's is 0, which means if sinabi nga po dito, if the result is 0, the received data is accepted. So wala pong error sa ating data. Therefore, the conclusion is we accept the data. So this is how checksum works, and let's move on to the next, which is the cyclic redundancy check. So the last is the cyclic redundancy check. The last error detection, and it is like the error detection methods dahil nag-add din dito ng code in the end of the string. And this is true to all of the error detection methods na na-discuss ko. And dito naman, unlike the checksum scheme, which is based on addition, CRC is based on binary division. So as we can see in the examples, we have the binary division, and unlike sa checksum, gumagamit tayo ng binary addition. In CRC, a sequence of redundant bits called cyclic redundancy check bits are appended to the end of the data unit so that the resulting data unit becomes exactly divisible by a second predetermined binary number. So as we can see here sa parang flowchart po natin, figure 1, meron po tayong data, and it is nadadagdagan po siya nung n natin. And we have the divisor, which is the predetermined divisor. Yan, so divisor, i-divide po natin hanggang sa makuha natin ang pinakang CRC niya. Then this CRC is sent along with the data and marireceive po siya ni receiver. So gagawin lang po natin uli yung process, and nakikita po natin dito sa example, ang CRC is idinagdag lang sa pinakang data bits natin. So ganun pa rin po ang divisor, dinivide lang po ang ating data bits, and after nyan, if ang ating remainder is 0, like in this example, the incoming data unit is divided by the same number. If at this step there is no remainder, then the data unit is assumed to be correct and is therefore accepted. So in this case po, since ang ating remainder is all 0, then ang ating data is accepted. In the case naman po na ang remainder natin is not 0, a remainder indicates that the data unit has been damaged and transient and therefore must be rejected. So yun lang po yung pinakang flow ng ating CRC. So isa po ito sa mga ginagamit talaga, since isa ito sa mga pinaka-accurate na error detection method. And it is widely used, and lalo na po nakikita po natin siya sa ating mga laptops and computers. And ayun, ang cyclic redundancy check.
Good day everyone, my name is Brandon Joshua M. Erinco, and today I'm going to discuss the data link layer or the data link control. So first, let us define the data link control. A data link control is a service that ensures reliable network data communication by managing frame error detection and flow control. DLC is based on the data link layer of the OSI model. So what is the OSI model? The OSI model, or the Open Systems Interconnection model, describes 7 layers that computer systems use to communicate over a network. So what is the tasks that DLC handles? So the first one is its reliable link in packet transmission. The second one is recovery and error detection during high layer packet retransmission. And the last one is the error framing, which determines start and end packetization via 3 approaches: length counts, bit-oriented framing, and character-oriented framing. So, dumako naman tayo sa functions or protocols ng data link control. So, meron siyang 3 functions: the line discipline, flow control, and the error control na makikita nyo sa baba. So, first one is the line discipline. So, it is one of the function in second layer of OSI model. It answers the question, who should send now? So, syempre, di ba sa isang communication, kailangang may isang sender. Hindi pwedeng walang mag-send ng isang message kung walang sender. So, it determines which device can send and what it can send, kung ano yung i-send niyang message. So, it provides also the coordination of transmission and also coordinate with the link system. Now, let's proceed to the flow control. So, flow control is set of procedures that restrict amount of data sender can send before waiting for acknowledgement. So, dito, sumasagot naman to sa tanong na how much data may be sent, or kung gaano ba karami yung data na isa-send ng sender sa receiver. So, receiver has limited memory called buffer to store incoming data. Receiver has limited speed to check and process incoming data. So, syempre, for example, mag-send ka ng data from your computer to the cell phone. Alam naman natin na mas mabilis yung speed sa computer. So, dahil dito sa flow control, nire-lessen niya yung speed. Bale, sinasabi ng receiver dito na slow down muna. So, kasi nga meron lang limited na speed yung receiver. So, flow of data must not overwhelm the receiver. So what's the meaning of overwhelm? Means overload, ika nga. So receiver must inform sender before limit reach or buffer begin to full, and request sender to slow down, yun nga kung nasabi ko kanina, or stop temporarily. So itong flow control, meron siyang two methods. Ito yung stop and wait or send one frame at a time. So pangalawa naman is yung sliding window or yung send several frames at a time. So examples of data link protocols are Internet, point-to-point protocol or the PTP, HDLC, and the ADCCP. So dito yung last one is yung error control. So error control used for error detection and retransmission. So pag may nag-error sa mga frame na sinend ng isang sender, so madedetect yon and ipapaalam niya sa sender na may kulang or may mali sa data na sinend, kaya babalik ulit yon sa sender. So it allows receiver to inform sender about lost or damaged frame. So it coordinates retransmission of lost or damaged frames by sender. So itong error control, siya yung sumasagot sa tanong na how errors can be corrected. So itong error control ay may one rule. So ito is yung automatic repeat request or yung ARQ. So error control is based on ARQ. It means retransmission of data frame in 3 cases. So ano ba yung 3 cases na yun? Una is yung damaged frame. Kung may damage pa sa frame na sinend ng sender, lost frame, and lost acknowledgement. Anytime error is detected, then the NAK is returned and ARQ retransmit a specific frame. If frame is not recognized or damaged by noise, then it is considered as lost frame. And ARQ perform automatic retransmission. So, parang chain lang to na babalik at babalik lang din sa sender yung sinend na message kung may mali, kulang, or nawawalang frame sa sinend na isang message. So, ayun lang para sa data link control. So, ang next reporter ay si Romel naman na ang i-discuss is yung related din dito sa data link control na framing. So,
Hello, my name is Romel Chavez Laman. Discussing about framing, continuation of data link control. So, definition of frame. A frame can be defined as the digital data transmission unit in telecommunication and computer networking. A frame is a straightforward network packet in the packet switch system. A frame is a repeating structure that supports time division multiplexing in other types of telecommunication system. Typically, a frame contains frame synchronization benefits including a sequence of symbols or bits. It shows the starting and the completion of the payload data in the bits and the symbol stream it receives. When a receiver is linked to the system at the time of the frame transmitted, it avoids that information until it finds a new frame coordination sequence. So, yung frame, siya daw ay isang digital data transmission para sa telecommunication and computer networking, at yung frame daw ay nagko-consist siya or nagko-contain ng sequence ng mga symbols or bits. Dito din sa sinabi dito about sa it shows the starting and completion of payload data in the bits and symbol stream it receives. Madidiscuss to mamaya. So ayun, next slide na tayo. So, framing in data link layer. Framing is a point-to-point connection between two computers or devices consisting of a wire in which data is transmitted as a stream of bits. However, these bits must be framed into discernible blocks of information. Framing is a function of data link layer. So yung framing natin, isa siyang function ng data link layer na nagko-consist siya ng sequence of bits. Yung sequence of bits niya is nag-i-start siya sa 11011 kaya dito sa picture at nagtatapos naman siya sa 11011 din. So, parts of frame. Dito is yung mga part ng frame. Ito yung flag, trailer, payload, field, at frame header. Sa flag, dito yung starting point at completion ng frame. Next naman is yung trailer. Dito, include yung mga error connection at end detection bits. Tapos, sa payload naman, dito, nare-render yung messages or actual data. At last, yung frame header. Ito naman yung origin address target ng frame. Tapos sa header, meron siyang 3 main control field which is yung kind, sec, at ac. So sa kind, this field express whether the frame could be an information frame or it is used for management function like error and flows management or link management, etc. Sa sec naman, this holds the sequence variation of the frame or transcription of out of sequence frames and causing acknowledgement by the receiver. Then last sa ACK, this contains the acknowledgement varies of some frames significantly once piggy banking is employed. So, types of framing. So we have two types of framing, fixed size framing and variable size framing. So in this fixed size framing, the size of the frame is always fixed. That's why frame length acts as a delimiter of the frame. And it also doesn't require additional boundaries to identify the start and the end of the frame. For example, this kind of framing in the data link layer is used in ATMs, wide area networks. They use frames to pass the size known as cell. So in variable size framing naman, in variable size framing, we are in need of a way to outline the tip of the frame and also the starting of the succeeding frame. This can be utilized in local area network. So sa fixed size framing, dito daw is since yung the size itself is acting as a delimiter, it does not require any boundaries or it does not require to give the start of the frame and the end of the frame. So next naman is sa variable size framing. Here, the size of each frame to be transmitted may be different. Kasi the size of it, the size is not uniform for all frames. So, it must maintain the start of the frame at saka yung end of the frame. So, framing approaches in computer network. So, dito, yung una natin is bit-oriented framing. Most of the protocol use a 8-bit pattern flag 0610 as a result of delimiter to stipulate the beginning and so the end of the frame. Bit stopping is completed at the sender end and bit removal at receiver's end. So dito yung beginning natin is magsisimula daw tayo sa 0610. Then, yung end natin doon is same din, 0160. So, kapag nagkaroon ng problem, ng error, dito sa bit-oriented framing, is kapag daw, para ma-fix daw to, is kapag pag na-detect nito na merong 5 consecutive ones is mag-a-add daw yung sender ng 0 bago siya papunta sa 6. So, yun, pagka sinenda ng sender, makukuha na siya ng receiver. Then, pag yung receiver naman is nakadetect ng 0 sa nakadetect siya ng 0 sa 5 consecutive ones, is tatanggalin niya ito para bumalik siya sa original data niya. So, ayun. Next. So, dito naman, number 2, byte-oriented framing. So, byte stopping is one of the method of adding an additional byte once there is a flag or escape character within the text. Take an illustration of byte stopping as appeared on the given diagram. The sender sends the frame by adding 3 additional escape bits, and therefore the destination machine receives the frame and removes the extra bits to convert the frame into the identical message. So dito, yung byte stuffing is kapag naglagay ka ng escape sa data, yung kasunod nun is mako-consider nyo na isang data. So, ayun. Binary Synchronous Communication Protocol or BiSync. This is a lookout approach. The frame format outline is given in the figure below beside the bits. So, in the figure, we have SYN or Special Starting Characters, and SOH or the start of the header, and STX, which is the start of the text character, and ETX, which is the end of the text character. So the STX and ETX looks after the data part of the portion to circumvent the framing in data link layer error problem. In this approach, we have introduced byte stopping. This can be used once the frame compromise character. The bytes is stopped within the message to differentiate from the delimiter. Framing application. So, ito yung mga application na example. Ito yung sa adapter. So, whenever the 0 and 1s are sent to the receiver collects all the zeros and 1s. So, the physical layer of the receiver, that is the adapter, collects all the zeros and 1s, and it has to construct the frame. So, yung next example is computer. They are ready for data exchange when the sequence of bits are sent by the sender computer. Then it understands the frames that the sender sent the receiver. So, ayun yung ating framing application.
Flow control. It implies a sequence of steps that specify how much information can be sent before the sender must wait for a response from the recipient. It also informs the sender how much data it can send before having to wait for a response from the recipient. So basically, yung flow control is it helps the computer or devices, mga technology, to handle the data at an effective rate. So in short, how can it be sent effectively? So isa naman is flow control is the management of data flow between network node. So ano nga ba yung network node? Network node is a endpoint ng mga communication sa mga devices. So ang nangyayari sa network node is pag na-overflow siya ng data, since madami ng data na kukuha yung device, hindi na kinakaya ng device yung data. So it's either na magre-result siya sa data loss, na mawawala yung mga data na na-send, or mariretransmit siya or mariresend, ganun. So dito sa bottom right, makikita niyo na there are two types ng flow control: feedback-based flow control and rate-based flow control. So ano nga ba yung difference nila?
So yung una is feedback-based flow control. So what it does is when the sender sends data or information to the receiver, it transmits back to the sender that the data is received. So rate-based flow control naman is it restricts data or information that is being transmitted by the sender without any feedback or acknowledgement from the receiver when the sender sends or transfers data to the receiver at a faster speed to the receiver that it can't receive data at that speed. So una is example sa feedback-based flow control. So when a person sends a message and it says delivered rather than send, but both are good. But yung difference nila is yung delivered is yung na-send na yung message dahil may internet or network or signal yung person or yung receiver. Pero yung sent naman is wala talaga siyang network at all, like zero. So isa naman sa rate-based flow control na example is when a person sends a message through the internet but the receiver has not yet acknowledged the message, but it is connected to the internet. So yun nangyayari dyan is when the sender sends a message, minsan kahit may network or signal yung sender, hindi pa din nare-receive yung message na sinend ng sender sa receiver kasi minsan may nangyayari sa network. So ito yung nangyayari sa rate-based flow control. In the data connection layer, the phrase error control mostly refers to techniques for error detection and retransmission. When an error is discovered during the exchange, specific frames are retransmitted. This technique is also known as an automatic repeat request. Error control is typically performed in this manner. So later on, i-discuss ko yung automatic repeat request. So an automatic repeat request is a two-way communication system error control technique. To achieve reliable data transmission through an unreliable source or service, it is a collection of error control methods. So yung automatic repeat request is to ensure that the sender receives an acknowledgement from the receiving end where the frame or packet was correctly received before a timeout occurs. A timeout is a set amount of time that the receiver must have in which to deliver the acknowledgement to the sender. So dito sa bottom right, nakikita nyo is how or paano gumagana yung ARQ or automatic repeat request. So, ito yung mga ways kung ano nangyayari para lang pumunta yung acknowledgement na hindi nakuha ng receiver yung message na ma-acknowledge sa sender. So, yun yung purpose ng automatic repeat request. So, in error control, there are different techniques. Stop and wait, sliding window, then under sliding window, there is go back N, then selected repeat. ARQ means automatic repeat request. So under error control, there are noiseless channels and noisy channels. Under noiseless channels, there is stop and wait ARQ. So stop and wait ARQ is a protocol known as alternating bit. It is one of the simplest mechanisms or flow control approaches there is. So yung stop and wait, isa siyang telecommunications or inside ng telecommunications. So, ginagawa dito is nagsisend siya ng data or information between sa dalawang devices na nakalink or two devices that are linked. So, next dito is sliding window ARQ. It is a continuous transmission error control that is used for this method. So, yung sliding window is type siya ng noisy channels. And nangyayari dito sa sliding window is isa siyang imaginary box na kinocover yung frames na either isasend ng sender or anda lang masend yung message. So, ang idea here is isa siyang message passing where yung sliding window protocol allows the sender na mag-broadcast ng ilang frames or several frames until hintayin yung acknowledgement na nasend na yung message. So, next naman is go back N ARQ. So in go back and ARQ, it is a transmission process that does not get an acknowledgement packet from the receiver. It will continue to send or transmit the complete number of frames that are indicated by window size. The protocol for sliding window flow control is used. In the absence of mistakes, operation is the same as that of a sliding window. So in go back and ARQ is the same lang ng how sliding window flow control is used. So in go back N, yung sender is not required to wait for the first acknowledgement before sending frames. So in order to deliver the frames, well, first waiting the acknowledgement is the sender's window size. So dito is nakikita nyo yung figure 1. Yung window ng sender is nagmo-move siya by one or more slots covering the frames that can be transmitted next, and then leaving the accepted frame while the receiver begins to send the acknowledgement. So yung arrow yung bago bigyan ng acknowledgement, in short. So if it helps if any of the frames is received or corrupted at the receiver side, or the frame is lost, or the acknowledgement of the frame is lost, the timer at the sender gets expired and the sender retransmits all the frames in the sender's message. So if ever na ma-corrupt yung sinesend ng sender, it will either be retransmitted or mauulit lang siya. It will be mariresend lang siya. So next is yung selective repeat ARQ. So in selective repeat ARQ is where only data frames that are considered to be damaged or missing that are sent again. Only frames for which data is received are retransmitted by the sender. The complexity at sender and receiver makes this technique less common, and each frame must be acknowledged separately. So bali in selective repeat ARQ is yung frame lang na hindi na-send ng sender and hindi siya nakakuha ng acknowledgement is masasend ulit, and mas effective siya kumpara sa go back and ARQ. Kasi yung go back and ARQ is hindi agad mag-send ng acknowledgement sa receiver. Kung titingnan yung figure 1 sa figure 2 is mas nakakuha ng acknowledgement yung receiver sa figure 2.
So we have here multiple access schemes. This method was developed to decrease these chances of collisions when two or more stations start sending their signals over the data link. Carrier sends multiple access requires that each station first check the state of the medium before sending. So sa ating multiple access schemes is siya yung nagko-control sa pag-decrease or pag-avoid ng collisions sa ating medium access layer, which is sa method na to is i-check muna yung stations before sending a frame, which is yung purpose neto sa medium access layer is to avoid the collisions sa ating mga stations. So mamaya is i-discuss natin yung dalawang types ng multiple access schemes, which is yung CSMA-CD and CSMA-CE. And dito natin malalaman on how they avoid collisions in the medium access layer, or on how they decrease the collisions.
CSMA-CE, which stands for Carrier Sense Multiple Access Collision Avoidance, is a network protocol for carrier transmission. Like CSMA-CD, it is also operated in the medium access control layer. Unlike CSMA-CD that is effective after a collision, while CSMA-CE is effective before a collision happens. So CSMA-CE is hindi po siya ginagamitan ng wire or so itong CSMA-CE method is used for a transmission in wireless network, while yung naman CSMA-CD is ginagamitin siya ng wire or cable para mag-transmit ng ating data. So paano nga ba nag-work itong CSMA-CE? So kung if meron tayong isang computer na gusto mag-send ng data sa ating wireless network, hindi po siya nakaka-sense or nakaka-hear out or ng anumang collisions, well, unlike sa ating CSMA-CD na magsisense muna siya or mag-i-route ng any collisions bago sa ating transmission. While dito naman sa ating wireless network, which is SMAC, is wala pong involved na wire. Therefore, it's best for avoiding collisions. So I have here example. So let's begin po kung paano po yung CSMA nag-work sa ating wireless network as a traffic controller. So sa CSMA, kunwari we have here apat na devices, which is tablet, laptop, CP, and desktop. So sa ating CSMA, kunwari ito is nagtatransmit ng data, ito rin nagtatransmit ng data, and itong tatlong ito is nagtatransmit ng data sa ating wireless network. So ito naman is parang wala siyang ginawa kundi naka-stop lang. If itong device na to is gusto mag-send ng data, sasabihin niya is RTS, which means ready to send data. And then itong router, kapag na-receive niya na tong request ni tablet or ating isang device, sasabihin ng ating router or ang ating wireless network na stop transmitting data everyone. So mag-stop na tong tatlong to na mag-transmit ng data, and then i-access niya tong isang device na mag-send ng kanyang data. So mag-send siya ng data sa ating network, which is tong tatlong ito is parang naka-stop sila temporary. Then pag naka-stop na tong tatlong to temporary, mag-send na siya ng data sa ating wireless network. So basically, itong ating router, which means ito yung ating traffic controller sa ating collision, which means itong CSMA is good for avoiding collisions kasi nga po wala pong wires or cable na ganap dito sa ating CSMA. Carrier Sense ay CSMA CD. CSMA CD stands for Carrier Sense Multiple Access and Collision Detection. Is a network protocol for transmission. It is operated in the medium access control layer. It senses the share that the channel is busy broadcasting and interrupts the broadcast until the channel is free. And CSMA CD collision is detected by broadcast sensing from the other stations. Upon collision detection in CSMA CD, the transmission is stopped and a jump signal is sent by the stations, and then the station waits for a random time context before the transmission. So dito sa CSMA CD, in-hear out niya muna or sinesense niya if there is traffic na nagaganap sa ating transmission medium or operated layer. So pag na-sense niya na wala naman pong traffic sa ating transmission, mag-send na po siya ng kanyang data, each computer. And then kahit nag-send siya ng data, in-hear out niya pa rin po if there is collision. So pag yung ating computer na isa is na-sense niya na walang collision na naganap, therefore yung ating data na sinend sa kabilang computer is successfully sent kasi wala nga pong na-sense na collision na naganap sa ating transmission medium while sending the data. So we have here example for our CSMA CD. So we have here apat na computer, which so first kunwari itong computer na ito is mag-send ng data. So first is gagawin niya is magli-listen muna, papakinggan niya muna if may nagaganap na transmission sa ating cable. And kapag may na-sense siya or na-hear na traffic dito sa or may na-sense na nagaganap na dito na nag-send ng data, mag-wait itong computer natin na ito sa line niya. And pag na-sense niya na or na-listen na wala na ditong traffic, mag-send na tong data natin by each computer until makapunta siya dito sa pinakadulo. Kahit na nag-send na to ng data isa-isa sa ating computer, sinesense niya pa rin po if meron pong collision na magaganap And if kapag nalaman niya na walang collision na naganap sa ating cable, yung sender natin is malalaman niya na yung send niyang data papunta dito is successfully sent. So paano naman if itong dalawang computer natin is nag-send ng data at the same time sa pinakadulo, o itong dalawang ito is nag-send ng data at the same time, and then nag-transmit na sila ng kanilang data. So nag-transmit na nga po sila ng data, meron pong collision na magaganap dito kasi nga po yung focus lang po ng ating CSMACD is to send each computer lang, hindi po at the same time. And then ayun na nga po, merong collision na naganap, mag-stop sila na mag-send ng kanilang data, itong dalawang ito. Yun, nag-stop na sila mag-send ng data, magta-transmit na sila ng mag-transmit na ito ng jamming signal sa ating network. Itong jamming signal is ino-notify niya itong lahat ng computer na ito na meron na-detect na collision na naganap sa kanilang dalawa. And then pag na-receive na nila yung notify ng jamming signal na lahat ito, yung dalawang ito ay nag-cause ng collision, itong dalawang ito is mag-wait ng random of time bago sila mag-send ng kanilang data ulit. So yung pag-wait ng time ng dalawang ito, kunwari ito dapat is naunang mag-send, kunwari ito yung time niya is 10 seconds bago siya mag-send, tapos ito naman 15 seconds bago siya mag-send ng data. So after 10 seconds ng time, mag-send na to ng data sa kanya. Then pagkatapos naman siya natapos yung time niya na mag-send, itong isa naman is mag-send siya dito sa kabila. So ayun lang po yung yun lang po yung CSMACD. Mag-send sila ng kanilang data each computer lang, by each lang, hindi po at the same time. So here in our 1 persistent, it sends the shared channel first and delivers the data right away. If the channel is idle, if not, it must wait and continuously track for the channel to become idle and then broadcast a frame without condition as soon as it does. It is an aggressive transmission algorithm. Kumbaga bago mag-send ng data, yung ating station is mag-listen first sa mga channel to see if anyone else is transmitting the data at that moment. If nakita niya naman na yung mga channel is busy, then yung station po natin is magta-transmit po siya ng frame. Since yung stations po natin po is nag-transmit po ng data or frame with the probability of 1, when the carrier or channel is busy or idle, tinatawag po natin itong 1 minus persistent CSMA. So we have here non-persistent. It first assesses the channel before transmitting the data. If the channel is idle, the node transmits the right away. If not, the station must wait for an arbitrary amount of time, and when it discovers the channel is empty, it sends the frame. So before sending po ng data or frame, yung ating pong sender is mag-send po siya sa channel. If wala pong nag-send, if no one else is sending the stations, then yung ating sender is mag-send na po siya by itself. Though pag yung channel po is already in use, the station does not continually send, unlike po sa 1 persistent CSMA. P-persistent, it consists of the 1 persistent and non-persistent modes combined. Each node observes the channel in the P-persistent mode, and if the channel is idle, it sends a frame with a probability. If the data is not transferred, the frame will start with the following time slot. After waiting for a Q is equals to -1P probability random period. So dito po sa pre-persistent, it is po yung combination po ng P-persistent and 1 persistent. So dito po, paano po ba siya gumagana? Gagana lang po siya pag yung slotted pag kung yung time na yun is kung yung time niya na yun na channel is free na, saka lang po siya mag-work. So when a stations becomes ready to send, i-send niya po yung channel, kapag busy naman po, i-transmit with a probability of P. So bakit magta-transmit sa probability of P? If the station is gusto na mag-send, i-send niya pa po ito, i-send niya po yung channel, and if the channel is free, it has to check one more condition. If the time slot is para sa kanya na po, then doon lang po siya magta-transmit ng kanyang frame. So with a probability of Q is equals to 1 minus P, it differs until the next slot. So bakit nga ba? So if yung station is busy, it transmit with a probability of P. So hindi po siya immediately magta-transfer ng kanyang data. So with the probability of Q is equals to 1 minus P, it differs until the next slot. If yung slot na yun is busy pa rin, it either mag-transmit po siya ng data or frame, or differs again, or i-postpone niya po yung kanyang pag-transmit with the probabilities of P and Q. So this process is repeatedly until either the frame has been transmitted or another station has begun transmitting. If the unlucky stations nag-act po siya na if there has been collisions, then mag-wait po siya ng random of time, then mag-restart po again siya. At ayun, pag nag-restart po, meron pong collision na nangyari. So dito po sa P persistent, pag yung station na to is initially sense the channel is busy or hindi pa po sa kanya yung slot na yon, hindi pa po siya mag-appear if hindi pa po siya mag-send ng data. If para sa kanya na po yung time na yon, then doon lang po siya mag-send ng kanyang data. O persistent, a supervisory node gives each node transmission order. Nodes wait for the time slot according to their allocated transmission sequence when the transmission medium is idle. So dito yung supervisory node po, siya po yung nag-handle ng transmission order para sa mga channel na nandito. Pag yung transmission medium po ay busy, then yung supervisory node magigib ng sign na mag-transmit na sila ng kanilang data para mag-transmit na po sila ng data. Mag-transmit na sila ng data sa kanilang slotted location po na destination.
FDMA or Frequency Division Multiple Access. FDMA is one of the most common analog multiple access methods. The frequency band is divided into channels of equal bandwidth so that each conversation is carried on a different frequency, which means the frequency band is separated into equal bandwidth channels to separate conversations. There are applications that uses FDMA or Frequency Division Multiple Access. Number 1 is telephone system. Telephone system is communication system that transmits sounds between distant points. Number 2, radio system. Radio system means a set of networks, software applications, databases, radio components and infrastructure, and operations and management procedures required to provide communication services. Advantages and disadvantages of FDMA. Advantages of FDMA: reduces the bit rate information and the use of insufficient numerical codes increases the capacity. It reduces the cost of lowers and intersymbol interference. Equalization is not necessary. An FDMA system can be easily implemented. A system can be configured so that the improvements in terms of speech encoder and bitrate reduction may be easily incorporated. Since the transmission is continuous, a smaller number of bits are required to a synchronization of framing. The disadvantages of FDMA. It does not differ significantly from analog systems. Improving the capacity depends on the signal to interference reduction or a signal to noise ratio. The maximum flow rate per channel is fixed and small. Guard bands leads to a waste of capacity. Hardware implies narrowband filters which cannot be realized in VLSI and therefore increases the cost. TDMA or time division multiple access. A time division multiple access is a digital cellular telephone communication technology. It facilitates many users to share the same frequency without interference. Its technology divides the signal into different time slots and increases the data carrying capacity, which means it lets users to share a frequency without interference. It separates a signal into time slots to boost data capacity. TDMA application. In North America, a variant of TDMA called North American TDMA is used. Almost all 2G cellular systems use TDMA, including the Digital Advanced Mobile Phone Service, Global System for Mobile Communication or GSM, Personal Digital Cellular or PDC, and Integrated Digital Enhanced Network. Advantages and disadvantages of TDMA or time division multiple access. Advantages for TDMA: permits flexible rates. In other words, several slots can be assigned to a user. For example, each time interval translates 32 kbps. The user is assigned to 64 kbps slots per frame. The other one is constant gust or variable bitrate traffic. Number of slots allocated to a user can be changed frame by frame. For example, 2 slots in frame 1, 3 slots in the frame 2, 1 slot in the frame 3, frame 0 of the notches 4, etc. And no guard band required for the wideband system. The last one is no narrowband filter required for a wideband system. The disadvantages of TDMA: high data rates of broadband systems require complex equalization. Due to the burst mode, large number of additional bits are required for synchronization and supervision. Call time is needed in each slot to accommodate time to inaccuracies due to clock instability. Electronics operating at the higher bit rates increase energy consumption. The last is complex signal processing is required to synchronize within short slots. CDMA or code division multiple access. The CDMA is a sort of multiplexing that facilitates various signals to occupy a single transmission channel. It optimizes the use of available bandwidth. The technology is commonly used in ultra-high frequency or UHF cellular telephone systems. Bands ranging between the 800 MHz and 1.9 GHz, which means multiplexing that lets numerous signals use one transmission channel. The technology is utilized in 800 MHz to 1.9 GHz UHF cellular phone systems. CDMA application. There are applications that are using CDMA like wireless modems and radar navigation. Wireless modems are devices that allow computers to connect to a wireless local area network without physical cabling such as internet wiring. Number 2 is radar navigation. Radar navigation is utilization of marine and aviation radar systems for vessel and aircraft navigation. Advantages and disadvantages of CDMA. Advantages of CDMA. CDMA requires a tight power control as it suffers from near-far effect. In other words, a user near the base station transmitting with the same power will drown the signal out. All signals must have more or less equal power at the receiver. Rig receivers can be used to improve signal reception. Delayed versions of time, achieve or later. The signal, multipath signals, can be collected and used to make decisions at the bit level. Flexible transfer may be used. Mobile base stations can switch without changing operators. Two base stations receive mobile signals, and the mobile receives signals from the two base stations. And last, transmission burst reduces interference. Disadvantages of CDMA. The code length must be carefully selected. A large code length can induce delay or may cause interference. The time synchronization is required. Gradual transfer increases the use of radio sources and may reduce capacity. As the sum of the power received and transmitted from a base station needs constant tight power control. This can result in several handovers. Again, this is Group 3 and that's all for today's report. Thank you for listening.